Here, going to do a video. It's going to be really quick. I'm going to jump on here and jump off. It's January 11th, 2020. Yeah, we just took a hit, a pretty good hit, but it was very, very short-lived. We were expecting that CME to get here today or later today, or like right around now or maybe a little bit later. I don't know that this was that CME, because CMEs tend to last longer than this did. Plus, I was showing you guys yesterday that, we had a solar wind stream right behind it that was supposed to hit us like 12 to 24 hours after the CME got here. But I also told you guys that if that speed of that wind was to increase or change, that it could actually get here at the exact same time the CME did. Now, whether or not that happened, I'm not sure. But what I can say is this is a definite hit. Okay. Here we go. Hit, compression, rapid expansion. Okay. Now, somebody asked me what rapid expansion and why it happens. Well, what happens is we compress. Watch. Okay, and then we push back out. We expand out real far. Now, why does it do that? Well, it's kind of proportional to the hit we get. Okay. So, however hard we get hit, we're going to push back, proportionally to that. So, the harder the hit, when we do it rapidly expand back out, we typically go out further than what a normal hit would have caused. Okay. Now, is that a big deal? No. It's just something that happens. And I say this just so everybody can kind of get an understanding of what's happening here and don't freak out over it. Okay. This is nothing to freak out about, and it's just not. You go back 5 years ago, the only difference now is our magnetic field is weaker. So it's not going to take as much to give us an issue. So here it is on the density. Remember on this one, the white color is very, very low density. Okay. And there was something else I really wanted to show you here real quick. If I can stop it there. There it is. Okay. See how it's more of a straight line? Now, most people would look at that and they would think, my gosh, what happened there? Is our bow shock gone? Well, I can tell you the bow shock's not gone, because I went over that a couple times here on my channel anyway. But you can kind of see it arcing over here. It's bending over here on the side. If our bow shock wasn't there, it wouldn't do that at all. Okay, so there you have it. I mean, but it is strange that this came in such a flat way. I mean, so yeah. And again, guys, it's a two-dimensional model trying to show us a three-dimensional thing. So that's where the discrepancy comes in. So let me go over here to the pressure one. This one actually is, and you're going to see, it's just going to go straight to red. See that? So to me, that's not solar wind. Solar wind would typically kind of have a ramp-up period where it would change color very, very slowly. Not real slow, but more of a moderate pace instead of just bam. This looks more like a solar flare signature, but I can tell you that I don't think it was. And the reason being is I went and looked at SDO and I didn't see anything. Now, I'm not saying that we didn't, because I could be wrong. I could have just not seen it. But in my mind, it's more likely that this has something to do with the CME that was heading this way with that solar wind stream. Okay, now, most of the people would look at this and say we're wide open, right? Well, we're open up here, but we got to keep in mind that our bow shock's up here, okay? So what's happening is the bow shock could still be fending stuff off. Whatever gets past that, this would be an easier way for it to come into come inside our atmosphere, give us that energy there, okay? That's all that means, all right? Yes, that is opened up some there. And like I said before, electricity is very much like water in the sense that it will find the path of least resistance. It's just what it does naturally, okay? So if it's not resisting there, it would make sense that we would get more energy that right there in that spot. So let me play this one more time. We are going to go look at the Australian model real quick. Okay, there it went right there. Okay, where we at here? I'll let you watch it here too one more time, just so you guys get a good idea of what's happening. I mean, it's an impressive hit. It just didn't last long. Do I expect us to see more? I don't know. I mean, I don't think that this is all we're going to see from that CME in that solar wind stream. I do think that we'll see more of that. Now, is it going to be something as bad as this? This isn't bad. That was the wrong word. Okay? As intense as this is what I should say. All right? Because this isn't nothing to be scared about. I can tell you now, if our bow shock had went down, if the bow shock wasn't there and we got hit with a flare, yeah, we wouldn't be having this conversation because electricity would be gone. It would fry our lines. Okay? I mean, that's just what would happen. Look up Carrington event. I've talked about that a lot of times here on my channel, and I'm sure I'll talk about it again. But again, what I'm seeing here, guys, is it's not normal to see that straight of a line there and then have this doing this back here too. Yes, we always have that tilt, but it's typically like this. We don't usually see this stuff come out like that. That's what I'm saying here, guys. Okay? Now, I'm going to go check those other models, and then I'm going to pause real quick. All right, guys, this is the Australian model. Okay, you see it jumping around pretty good there. I'm going to show you how quick this can change. Okay, I'm going to get to the right timestamp here. All right. Now, let's see here. Let's play it. Okay, yeah, it just went right there. Went too far. Okay, so what you're going to see... Well, I went too far again. Sorry. All right, that's a good place to stop right there. Again, number one, the density is really, really low again. It's 0.1. I've seen it go to 0 again. We're way out in the front. You see our bow shock's way out in the front. It even actually goes off the screen, like I showed you in my last video. But in 1 minute, watch what happens. Boom. Okay? That's a 1 minute thing. Sorry about that, guys. It's stupid thing. Yeah. But yeah, you've seen what it did, right? There it is. Okay. Yeah. So it goes like that. 1 minute goes from that to that. So that was a pretty intense hit, guys. Yeah. Okay, guys, this is the other models I use and show you guys. It hasn't updated yet. At 8:06 was the last capture we got. This happened at 8:28 UTC. Okay. So, yeah. I'm just going to wait for that to come up. So, but I did want to show you guys that is down right now. It's probably just a safe mode thing. But, again, I could be wrong. But, yeah. So, I'm going to pause it. Okay, guys, I'm having to change something here, what I just said, okay? I told you that it was down, right? I mean, we looked at it, and the last update we got was at 8:06. Well, if we go down here to the graphs, I looked at this about 30, 40 minutes ago, and there was one showing a spike of 40 on the density, okay? Well, now it's flatlined, right? And it's getting its data from the same place. So if it's showing you data here, it should be showing it up here too, and it's not. So how do we confirm that? Well, if you go down here and you look at the time, you can see that it gave us captures. It gave us data points there, I should say. That's 11:30 UTC right there. Okay? And we were looking at 8:28. So this thing is still getting data, but why aren't they putting it into the model? That's pretty puzzling. It's actually pretty suspect. Just saying. Because if you look at this doesn't look very impressive. But what I just showed you guys was pretty impressive hit. Okay, so what happened? Are they just not letting us see that now? We'll know more later on today when this thing comes back up. It could come back up really soon. I don't know. But if it went down for safe mode, we shouldn't be getting any data from it at all. Okay? It makes no sense that these models aren't updating, but the graphs are. Okay? So, anyway, I wanted to bring that to you. Okay, guys, we always look at the earthquakes when we're talking about energy like that, like we just seen. Now, remember, that was supposed to happen at 8:28 UTC when that hit us. Well, if you look at the timestamps on this is very, very close to that. Okay, we're not seeing the 2.0s or nothing. We're seeing a 5.1 and a 5.3. Or is that that's a 5.1 and a 5.1? Sorry, but yeah. So if you think that solar weather has nothing to do with earthquakes, I think you might want to rethink that. But yeah, I do think that this is something that we always look at and this is just kind of a little bit of validity that we've seen that big smack, and then all of a sudden we see these 5.0s popping off. Okay, is it unusual to get 5.0s? No, but for them to be back to like a couple different ones right there after we got that pretty big hit, it's probably related. So anyway, okay, before I let you guys go off of here, I wanted to show you this one more time. This is that CME tracker, guys. Okay, there's that CME. Now, if you look at the timestamp, the time dates, it's up here. When that stuff gets here, it's on the 11th. Okay, so this model hasn't changed since, and it wouldn't update unless there was another CME coming right at us. Okay, but it's saying that this should be here on the 11th, so this very well could be that CME. But the other CMEs I've ever seen, though, is more than just a quick little pulse. Okay, that's why I'm having a hard time just completely saying that it was a CME. So we'll leave it at that. But you can see this is the one I explained to you guys yesterday. You see the little hazy area around the Earth? Watch, just like that. You see that? That's the energy getting here. Why is it straight line like that? Well, I explained this yesterday. I'll do it real quick again. This one here on the left is a top-down view. Okay, here's the sun. There's the Earth. This is a side view. And what this is, it's a straight line. But what it's representing is they take this orbital path of Earth and they stretch it out in a straight line. So it gives us a better sense of direction. That's why all three of these are here like this. Because then we can tell if it's going to go above us, below us, to the east, to the west, that kind of a thing. Okay? And if you look at all three of them, then it does kind of give you more of a better idea of, three-dimensionally anyway, of what's going on. So, but anyway, guys, I think I am going to end it there. I got some more stuff to talk about. I may come back later on. If that ISWA model does update, we'll check it out. I did not see any solar flares, though, so I don't know that if it was that. I don't think it was. But we do have what they call stealth flares and stealth CMEs, stealth solar storms. They're very hard to see. Matter of fact, they call them stealth for a reason, guys, obviously, and they're hard to see. We don't catch them. Sometimes we get these hits. Something else. I did not see any kind of signature showing me that could have been like a cosmic ray burst. Okay, because sometimes that's something we look at also. But I don't think it was a cosmic ray burst. So yeah. So my guess is it's related to the CME that's supposed to be here today. So, and I'll just leave it at that. God bless. Sheila saves, and you can drink this Kool-Aid.